Slow speed, ultrasound is exceptionally good for slow speed. Vibration has some challenges for slow speed bearings. Here's an example of a couple of slow speed bearings. This is on a stand. This is actually at a roofing facility. So they're making flat roof type material. And this is a big spool of the material that's being pulled into a machine for processing. And we've got a bearing on either side. So let's listen to the front bearing. Very smooth, very quiet. A couple of evidence of impacts in here, but this is actually a natural part of the process. There's all kinds of ridges in this. So as it turns, it kind of pulls and you end up with these little ridges that it goes over. Very smooth though. Let's compare it to the other side, the bearing at the back here, and see what this sounded like. So you can hear quite clearly that kind of scraping metallic noise as it is turning. So the bearing is actually moving in the housing. There's a lack of lubrication there, just doesn't sound very healthy. From a qualitative standpoint, comparing two similar bearings to each other, quite a huge amount of difference. Not a lot of energy being produced. So plus or minus 10 dB, plus or minus even, these impacts go a little bit higher, up to plus or minus 25 dB microvolt. But it's the characteristics of the bad bearing that really stand out as opposed to the absolute energy that's being generated.